Hello, I am Tom, your virtual instructor. Stay with me until the end of this video and you will see how CPU addresses I/O modules, how user programs execute in CPU, and how to create your first PLC user program in TIA Portal. So let's check it out. Before we continue with an example in TIA Portal, let's recap how PLC works. After PLC is powered on, first it executes the startup task. During startup, CPU will call up Startup Organization Block, or shorter Startup OB. That is called also OB100. The OB is routine where user program is placed and executes. This OB executes only one time during startup of PLC. Here can be placed some program code which will executes only during startup. Usually it is initialization of some values. More about organization blocks in the other video. Then the next step is read inputs. After that the CPU will execute the user program. User program executes in the organization block or main routine, which is also called OB1. In OB1 is placed PLC user program. In OB there are lines which are called networks, and they are numbered as network 1, network 2, network 3, etc. It executes one by another from the first until the end. After execution of the user program is finished, CPU will update outputs. This process repeats again and again. One cycle starting from reading inputs until update outputs is called PLC scan cycle. User program is executed by the CPU. The CPU is the brain of the PLC. Reading inputs is done by input modules and updating outputs is done by output modules. To illustrate what actually this PLC scan cycle means, let's assume we have a machine controlled by PLC. So statuses from sensors are read by input module. Then execution of user program is in CPU, and at the end update of outputs via output modules, and by this actuators get the commands. All this is one PLC scan cycle. After one PLC scan cycle is finished, the new one starts. Duration of a PLC scan can vary and will not always be the same. Typical PLC scan cycle takes around millisecond, depending on capability of CPU and user program load. Let's analyze one example. We have connected one indication lamp to the digital output module and one switch to digital input module. An in PLC program will execute simple PLC logic. Once switch is activated, the indication lamp shall light up. This example will help us to understand how the CPU addresses the I/O channels and how the user program is executing in CPU. How does the CPU address the I/O channels? The CPU has an address range reserved for communication with peripherals such as I/O modules. Number of available addresses depends on the capability and performance of the CPU, so different CPUs have different amounts of available addresses. Address range consists of bytes. Each byte is 8 bits long. There is an address range for inputs and also for outputs. For each channel shall be assigned address from address range of the CPU, and on this way CPU exactly knows distribution and addresses of each channel, and CPU can read status value from any input channel and send command value to any output channel. Number of bytes required for addressing the I/O module depends on the I/O module. In our example is digital input with 16 channels which requires 2 bytes, same for digital output module. For each I/O module shall be defined start address, and distribution of addresses to channels shall be checked in user manual of the I/O module. For example, the digital input module start address is 100 and the same start address for digital output module. First 8 channels occupy byte 100, and the second 8 channels occupy byte 101. One input or output module must have a unique address. In this example, in case of having another digital input module, the first free address that can be assigned is 102. Finally, in this example, digital switch is connected to the digital input module at the channel which occupies the address at 4th bit in byte 101. In case of output channel and indication lamp which occupies address at 0 bit in byte 100. CPU access to corresponding address and reads or writes a value. Address format is following: I, or Q, represent that it is input or output. Then number and front of decimal point represent byte number. Since number behind decimal point represent bit in corresponding byte. Value can be true or false since it is a digital signal. Now let's have a look at the configuration of the I/O module start address in TIA Portal, and let's make our first simple PLC user program. If you like this video, click the like button down below, subscribe and a bell. In hardware configuration we have inserted one power supply module. Here we can see details of module, and unique article number. One PLC 1513-1, one digital input module with 16 channels and one digital output module with 16 channels. At the right side is a window called Device Data, and if we expand it we can see a list of inserted modules in tabular form. There are column input addresses and output addresses. We notice that input address is possible to adjust only for input modules and output address only for output modules. Here we will enter the start address. As an example, we will populate this field with 100 for the start address for input and also for output. Here already we can see that it occupies 2 bytes because there are 16 channels that are 2 bytes long. Down in the properties of the module there is card, I/O tags. Here we can see the address list of all channels of the selected module. Here we can populate with a tag name. In our case for input I101.4 we write, switch. This is the unique symbolic name of the tag since I101.4 is a unique absolute address. Both addresses shall be unique and shall not repeat. In case we make 2 tags with the same symbol address or absolute address we will be notified by the compiler with an error. Beside the symbol and absolute address here we can see data type. In our case it is bool, since it is a digital signal. More about data types in another video. For output address Q100.0 we can write the tag name, lamp, since at this address we have a connected indication lamp. At the left side under folder, Program Blocks, we will find Organization Block OB1 which is the main routine, and inside we will create one simple logic. All what is written in OB1 will be cyclical executed as it is explained at the beginning of this video. This is ladder programming language, and we will insert one normal open contact where we write symbolic address, switch. More about programming languages in another video. Here it appears beside symbolic address, absolute address as well. On the other side we will insert one coil and write, lamp. Actually, this simple PLC logic will transfer the status of input I101.4 to output Q100.0. Simply, if I101.4 is true, then Q100.0 will also have the same value true. Let's go back to the example. Once somebody activates the switch, we get input I101.4, which shows an indication lamp at the module itself, and also we can see in the PLC user program, online, status of input address. Based on the PLC user program, we will get true at the output when the switch is activated and the indication lamp will light up. If you followed this video carefully, then congratulations. You have created your first PLC program. So that was it for now. If you like this video, click the like button down below, subscribe, and a bell. Thank you for watching. See you next time.